Daryl's going to do an intro.
Great.
So welcome everybody to today's seminar, and today's speaker is Andrew Ross. He's the Manager of Health and Safety at the City of Vancouver. He previously completed his master's degree in occupational environmental hygiene at the UBC School of Environmental Health, where he worked as a teaching assistant and research assistant while completing his thesis on metalworking fluid. He worked for Worksafe BC as a senior research assistant before obtaining the position of occupational hygiene coordinator for the City of Vancouver in 2000. In 2009, he accepted the position of Manager of Health and Safety, and the broad positions he has held so far are the Vice President of British Columbia Municipal Safety Association and the Chair of the Vancouver Civic Employee Assistance Association. He's also a past president of the OEH BC Yukon local section. So join me in welcoming Andrew Ross, who will be talking about resolving pool chloramine exposures with UV water systems.
Great. Thank you. Thrilled to be here today. Just wanted to start with some acknowledgements, and that is that UBC has actually been a huge contributor to what I'm going to present today, and I feel badly that I haven't come back sooner to discuss the contribution that UBC has actually played into this presentation today. I guess starting with certainly the lab upstairs. I'm assuming it's still upstairs, but Tim was a lab manager at the time of when I was working there. There was a postdoc girl student named Hind, and I apologize, I don't remember her last name, but she was a help and did some statistical work for me, which was great. In fact, a whole series of many years of students, because it was part of the lab, can't remember which one, but anyway, it was Mike's lab, or when I was a student here anyway. I think Hughes taken over it. But anyway, hygiene students would go out to City of Vancouver pools and practice sampling for chloramines, or the particular nitrogen trichloramine. And so some of the students' lab work is included in my presentation. And also wanted to acknowledge both Winnie and Hugh for being very supportive of kind of the sampling that we did at a bunch of the pools to help us with what is the chloramine exposure in City of Vancouver pools. Oh, and I want to sort of set the scope and expectations around this, is that this isn't a hardcore study. I don't have lots of statistics. And originally this presentation was created for more of a lay audience, mostly municipal recreation staff. I've presented this before. And also to British Columbia Municipality, the safety, at a safety conference that they hold as well. So it's kind of light on science, but it's a good story nonetheless. So just today, just with kind of the overview of the whole presentation, I want to get into how chloramines are produced and kind of what they are, the health effects of these compounds, a little bit about the determinants of exposure for chloramines and exposure and their creation in pools. I'm going to run you through a bit of a case study of a new pool that came on stream and we had some real problems with. And out of that case study was exploring UV or ultraviolet light water treatment systems to try and help us with getting rid of these trichloramines. Then a little bit of science starts. I'll get into trichloramine exposures at local pools, and then get into some of the pros and cons, and kind of, you know, not every control is perfect, and it's a little bit of a lesson around some controls may seem like the perfect solution sometimes, but they do have side effects from time to time. And then some other trichloramine mitigation options that I was going to just briefly talk about. So, what is trichloramine, or what are chloramines and how are they produced in the pool environment? And as I warned you before, this is more for a lay audience, so hence the slide. So basically, what we're most concerned about is trichloramine, and that's that sort of gaseous cloud on the right-hand side of the screen there. And how we get to trichloramine is basically people peeing in the pool, but also from sweat, from pool users, lotions, any kind of substance with a nitrogen base in it, because it's the nitrogen eventually gets worked on by the chlorine that's introduced to the pools for disinfection, and we end up with trichloramine gas. So just kind of running you through the kind of the basic chemistry there. The OHCl is basically liquid bleach that's introduced into City of Vancouver pools as a disinfectant. Some systems will use a gaseous chlorine to introduce in the pool. And there's also ozone. The City of Vancouver has one ozonated pool too, but it must supplement by law with chlorine as well. So anyway, as the urine mixes with the bleach, you get a compound called monochloramine. Monochloramine dissolves easily in water, and it tends to like to stay there. Monochloramine further gets worked on with the bleach, and it creates dichloramine. And so both mono and dichloramine are usually associated with irritating eyes in the pool, from opening your eyes in the pool. So they're irritants that remain within the water. And then finally, the last step of the chemical reaction is the creation of trichloramine, which is very hydrophobic. So it eventually off-gases out of the pool water. So it doesn't want to be in there. So that is the basics of how chloramines are produced. So kind of after this, most of my talk is really going to be referring to trichloramine, although I'll probably slip in and out of saying trichloramine or chloramine, but I more or less mean the same thing. So kind of the chloramine health effects. So as I have already mentioned there, is that mono and dichloramine are associated in pool water or even aerosol in the air, and it's linked to irritation of the eyes and the respiratory tract to some degree. But it's trichloramine where most of the studies in the literature focused on, there's a fairly close association of trichloramine and occupational asthma, also in childhood asthma. They've done a lot of study in the Netherlands on that linkage there with childhood asthma. It can cause acute respiratory irritation if the concentration is high enough in the air of the pool, around the pool. The technical name is a nanotorium, which is a bit of a mouthful, but and then an interesting fact is trichloramine has the same irritancy as chlorine gas. It doesn't have the same kind of chemical reactivity, but if you look at the MSDS sheet for trichloramine, studies show that it's equally as irritating as chlorine gas can be. So more around the determinants of exposure. So like I said, trichloramine doesn't like remaining in pool water. So any kind of agitation of water affecting the surface of the water is going to increase the off-gassing process. So if you've got a lot of swimmers kicking and splashing, you're going to have higher levels released. You're also going, if you have higher beta load, you've got more people potentially peeing and sweating in the pool as well. So you got to take that into consideration. Increasing water temperature, obviously it just the heat drives chemical reactions. And as you can probably imagine, most pools have a nice big swimming pool and a hot tub. And you'll see that hot tubs play into the story as I move along here. Poor bather hygiene, as I said, increased water agitation. One of the things about new pool construction now is there's a real drive on the recreation side for kind of more amenities for the patrons. So more water features, spray features, rapids, slides, all this kind of thing to increase the fun of the patron. But on the flip side is it's driving this agitation process, which is making it actually less healthy for patrons to be there. So, you know, there's competing demands on that sort of financial patron side and then on the health side as well. And obviously, you know, my real concern is around all of our city staff who work around the pool. You know, lifeguards and swim instructors, that sort of thing. And then a few obvious ones on the determinants that have been done by various studies, mostly in Europe, actually predominantly in Europe, are they found that if there's less fresh air dilution, you know, it makes sense. There's less dilution, your chloramine levels or trichloramine levels will go up. And then they've also found if pools don't monitor their pool chemistry and they start becoming acidic, that drives that chemical reaction. So it favors acidic conditions, the creation of trichloramines. Feel free to ask questions too if I'm not making sense or if you got a burning question. I'm very happy to answer midway through here. So moving into our case study, I'll just refer to it as pool number 5, but it is part of the City of Vancouver inventory of pools. So in this facility, so this is in its new state, but there was considerable changes, and my apologies to those of you following on the internet. So in the top left-hand picture, up on the top there, you can see there's a whole bank of ducting, and then there's that whole new window area. And then below that ducting, you can see that there's a large hot tub there. And then there's the ramp down into the main pool. So basically, that hot tub being there, that's all brand new. So basically, the wall ended there previously, and so they built on. So the next picture on the top right sort of shows that atrium. That was all brand new, created and pushed out the side of the building. And then just sort of drawing your attention to this lower right picture, you can see there's a sauna there, and then there's a window that's into the weight room. That's where the hot tub used to be. It was in a little enclosed space in there. And then above the rescue hook there, or just below the rescue hook and next to the life-saving ring, that is the main exhaust air duct for the pool facility there. So when they opened up this facility, you know, everything was empty of water. They filled up all the water, properly chlorinated, made sure the HVAC system was running properly, and the staff complained horrendously about the irritating trichloramine. There was one person who had natural asthma, who their asthma was hugely exacerbated, and this woman had lived there, had worked there for many, many years, and this had never happened before, and we actually had to place her at another facility because she could not work in this environment anymore. And basically all the staff complained. And so then it was like, we have to fix this. You know, just a lot of money was just spent on this pool, and we got to get it up and running and make it an enjoyable experience for patrons. And patrons were complaining too. So some of the things they were checking was, well, do we have proper distribution of the water flow? Like, do we have stagnant zones, which, you know, can be an issue? And so we did dye tests in there in the pool. There was a number of tests done on the direction of the airflow, and there's a couple of small problems of the direction of the airflow where the air wasn't going smoothly over the ceiling, and that's sort of what you want is in the pools, is because you don't want air blasting down on the patrons, because then they get cold and they complain. So there's always that aspect you have to be mindful of as well. There you can see a chair with a monitor going near the exhaust area of the exhaust vent for the whole pool. And so some of the things they were doing was they were trying to run at 100% fresh air, and still complaints. Even though it was like, down the cost of heating all that air, we'll run 100%. And this was going into the winter time when the pool opened. And that wasn't helping. And then they started diluting the water tremendously. And that was having some effects, but we were going through, you know, thousands and thousands of gallons every day. Like, this wasn't a long-term sustainable. And then you got to reheat all that water. So once again, you know, spending thousands and thousands more in heating costs. And then at one point, they took the hot tub off stream, and everything was great. Everybody loved it, except people were complaining because there's no hot tub. But all of a sudden we're thinking, okay, there's a hot tub here. This is going to be an issue. And they were doing superchlorinations, and superchlorinations is a process where you jack up the chlorine level to about 10 parts per million or higher in the pool, and it helps drive that whole process I showed you earlier of driving the trichloramine off. And that's basically how pools are cleaned, is that they do back scrubbing on the filters and they clean out the sand filters, and then you shock it with high levels of chlorine to basically get everything to off gas. And that's how you keep it. So they're doing this like on a weekly basis, and that's pretty rare to do superchlorinations on a weekly basis. So we were still having complaints. We were having, limited success, and so we started looking at. Here's some of the. Sorry, just launched into it. So we were getting a little desperate of what are we going to do next. So we're looking at one of the things that I came across was around UV. So remembering that this was a few years ago, as I said, back in 2006, there was more interest of introducing UV into drinking water, potable water systems. So that was sort of new water treatment systems were using it. But normally UV had always been used for killing off bacteria because DNA is sensitive to UV light at 254 nanometers in terms of the wavelength. And so that's where UV has typically been used. And there's different types of lamps. And the lamps, so low pressure lamps, use less energy for one thing, but they, just by fluke, also happen to put out a modest output at exactly 254 nanometers wavelength UV light to kill off bacteria. It works well for that. And then we knew there was medium pressures, and the nice thing about medium pressures is that they can put much more energy into the water. And it was really tough finding information on the internet, on published documents. And so with myself and an engineer within the Parks Board who'd been tasked with fixing this problem, with everything we found, we were pretty sure we wanted to try this UV option at this pool. We weren't sure about, should we use a low pressure lamp or a medium pressure lamp? And all the lamp manufacturers, they all wanted to sell us a low pressure system. And so eventually I stumbled across the name, and just by fluke, he was a professor at UBC who studies UV light in water and basically the destruction of different chemicals, mostly in drinking water. And so we marched out to UBC and had a chat with him, and he sort of set us straight and said, you should go with a medium pressure lamp. And on the basis of, with your medium pressure lamp, it coincides well with trichloramine destruction, which happens at multiple different wavelengths, and I'll show you a slide of that in a second. It also gives you a lot more energy, and that's what you need, is that high energy to break those chemical bonds, to get that UV light to break up the bonds of the monochloramine and dichloramine. And certainly for our case study pool number 5, we'd already noticed that our hot tub was where we were going to start. So this is sort of a pilot project with our hot tub, because it's hot. It's a small volume of water with a lot of people who sit in it, releasing Lord knows what into the water. So that's where we started. So it was a bit of leap of faith. So kind of the destruction process. So those 3 sort of molecules that I have circled. The first one on the left is the monochloramine, then a dichloramine, and then the trichloramine there as I've labeled as NCl3 on the end there. So as you hit that with some UV light, you end up with these reaction products of hydrochloric acid, nitrogen, and oxygen. So that was kind of nice. We're not really producing anything too terrible with this chemical reaction, as we could sort of find in the initial literature back in 2006. And so away we went. So, a little bit more about, so there's the peak. So as I said, the low pressure lamp there that they're using in portable water treatment, that little sort of purple bar I have there shows roughly the intensity and the wavelength in which it operates. As you can see, it's not a whole lot of energy and a very narrow wavelengths that it works under. This sort of orange line that runs up top, that's the peak DNA destruction. It's not a perfect match, but it's close enough and it does a good job. And then that sort of purple squiggly line that goes all over the place, that's roughly the peak destruction wavelengths for mono and dichloramine. And that's what we're at. Oh, sorry, the medium pressure lamp, this is where kind of that squiggly purple line is where the output, as you can see, is much higher. And then these little peaks. Actually, my next slide shows it a little bit better. So the dark black, that is the various wavelengths that the medium pressure lamp operates at. So, you know, a couple of pretty strong peaks in terms of energy. And then the blue line and the green line representing our mono and dichloramine. Green is dichloramine, and my slide's not quite right. Sorry about that. But anyway, that's the purple one should have been mono. But you can see around sort of 250, we have a reasonable peak that coincides with a peak destruction of the monochloramine. And you know, this little graph, I had to plot it myself using old journal articles from the 50s where they had actually gone in and looked at plotted intensity. Like, none of this was at my fingertips, and that was some of the excitement and challenge of this whole assignment, to really understand what was going on with this whole process. So what does it look like kind of when it hits the pool? It's a very simple setup. It easily bolts on to the existing pipes that are in the basement of the pool. So basically, water comes out of a big sand filter, so all the hair and other solid particulate have all been strained out. So you've got nice clean water that enters the top of your system. It runs through the system, and the light bulb runs the whole length of that horizontal section there. And then you've got your lamp inside that's high energy, exposing the water, and then you need that distance for the residence time so that you are getting high energy light for a certain period of time, and that's your dose of energy to break up your mono and dichloramines. And then it leaves the system, then you add your bleach, and then it gets pumped back out in the pool. So, I couldn't, off the top of my head, seconds, like fractions of a second. So if you imagine, this is thousands of gallons that are probably running through here. So it's not very long. And like I said, the unit really is about this big, so it's not a whole lot of time. And usually the lamps are sized, like it is all engineered between the intensity of your lamp and they calculate it to the residence time. And the salespeople will make sure that your pump flow has to be, it's all lined up. So you really need to pay attention to what is the volume of water so that they can size either the right lamp or the right length of tube to get that perfect residence time in there. So that's the system in a nutshell. So kind of getting into what kind of effect does this have? Or this is, actually, I'm going to launch into a little bit about how big is the problem and around exposure limits and everything else. So out of the gate, there are no exposure limits. However, a French researcher I guess the 1990s proposed a guideline limit of, sorry, that's supposed to read 0.5, not 0.05, sorry, for the typo, as a guideline limit. And some of the data I have plotted up there is a study done by UBC, or Worksafe BC, because they showed an interest in trichloramines in pools at one point. So the Worksafe BC study number 1 is a unnamed pool in the Lower Mainland. The Worksafe BC number 2 is the City of Vancouver's ozonated pool, because that was sort of seen at that time as state-of-the-art. So you can see there's definitely a difference. I'm not going to say a significant difference between the two, but eyeballing it, there is a difference there. And then a friend and colleague and peer who's a hygiene consultant, their consulting firm had done a number of tests at different pools around the province, and so they kindly gave me their data as sort of a comparator, and you can see that there's definitely a few pools out there that are exceeding these guideline limits. And the reason the consultant was there was probably because there were complaints by staff, and that's why they're going out to check it out. So, so that's kind of the state of pools, BC pools, and obviously with Worksafe BC, you have that target of trying to be roughly half of the exposure limit, or any guideline limit. So, thankfully our City of Vancouver pool was kind of just hanging off just below the target of 50% of the guideline limit. So what was also interesting about what WCB did is they sent it to a lab in the US somewhere that could look at mono and dichloramine, and that was something that sort of the UBC lab couldn't do. They could only measure for the trichloramine in terms of it's a different lab technique. So this was interesting, looking at what Worksafe BC had done and seeing that in terms of mono and dichloramine present in the air as an aerosol, like how much does that contribute to the overall irritancy of the air. And turns out that overall 9 samples is not huge, but are roughly 16% of all of the chloramine in the air is only related to the mono and dichloramine. The bulk of it is the trichloramine that's in the air. But they also, interestingly, did find some stratification and this is in the City of Vancouver pool, that is also ozonated. So in the breathing zone, and that right at the level of the water, the level of trichloramine was a little bit higher, and resting at about that 50% of the guideline limit there, with comparing this to 0.5. So we're on the edge, if you like. So this slide here is a composite of basically a whole lot of testing that was done by city staff who are normally involved with asbestos control and air sampling. And because I was very busy, I couldn't, as a hygienist, go out and do all the sampling myself. So I trained up this crew of staff, and they went out and did a lot of testing for me. And we set it up as a determinants of exposure study, and so we looked at multiple pools, we looked at different seasons, and so that's what the little squares and triangles, a dark square is in the summer, and a hollow, just an outline of a square, is the winter season. And sorry, squares are main pools and triangles are the hot tubs. So under pool number 1, you can see for the main pool, during the summer season, all of our samples tended to be lower than those samples taken in the winter. So right off the bat, we're seeing that there is a seasonal variation mostly due to changes in the ventilation system. In the summer, we run 100% fresh air. In the winter, we have to recirculate the air. And then generally, you can see kind of pool number 2 here, a couple of triangles that are up above that 0.5 of the guideline limit. So yeah, and so that, that's a first bit of results. Oh yes, question for you all. Your best guess. Between pool 1 and 6, any guesses on which one is the ozonated pool there? The state-of-the-art ozonated pool.
Pool 1, yeah.
Any guesses? Ed, you're saying 1?
I got it. Pool 6 with a pool.
Okay.
There's not much variation.
Okay. Anyone else want to hazard a guess? Pool number 4 is our ozonated pool. And they're ozonating both the main pool and the hot tub at that point in time. But it is also, has to be, the ozonated water has to be supplemented with bleach as well. So, and this is one reason actually what I forgot to mention earlier, why we did this sampling was basically pool number 5 was where we had all the staff basically going into a revolt saying, we don't want to work there anymore. So we basically had to come back with some kind of evidence to say it's the same, it's no worse, or if it is worse, then we really got to get on it. And so as we were doing the sampling and comparing, and certainly at the end of the study, it became very apparent that pool number 5 was no different than any of the others. And in fact, it was better than some of our other pools where no one was complaining. And as you make your way out into the world of doing hygiene for a living and safety, you'll find that sometimes you're in a PR battle. That's not always all for science and health. There can be many different reasons why you do sampling, and sometimes why you might not do sampling at the same time. But this is one thing that I personally had concerns, so I was really interested in the science that was coming out of it. But one of the big drivers for the rest of management was we need to prove to the others that we don't have, or hopefully we can prove that we don't have a problem. And ultimately we were able to show that pool number 5 is really no different than any other pool in our system. And so that is sort of the state of the nation before we had put in any kind of UV system. But we still went ahead and put in a UV system in pool number 5. And certainly there were still complaints going on at this time. So this took a while to collect because basically all the tests that were done after 2006 were basically done by UBC students doing it for their labs. And so everything that's circled there, those are all different pools that have had UV systems put into their hot tubs over time. And all these other data points, that is, I've taken all the other data and just put it into one line there so we can see the comparison. So a quick glance, sort of it's not a perfect study. I haven't done the statistics to show is it significant or not, but just kind of eyeballing it, you can tell that the UV systems seem to be helping and improving. And when it came to pool number 5, it was overnight. We flicked the switch. The next morning, the staff came in, said, this is perfect. Like, the qualitative assessment was 100% improvement. And it's happened every time we put the UV system in a hot tub. So, in the court of public opinion, it has far more weight than any kind of statistics I can show you here today. And then pool number 5 at one point went through another sort of mid-cycle refit, and they forgot to turn the light on after the refit. Staff came in, they were very upset. Oh no, here we go again. And somebody double-checked. They flipped the switch, and 2 hours later, perfection. The air was clear, there was no more stink in the pool. So it was quite incredible how effective these UV systems are. Even though I can't sort of prove it to you in numbers, sort of anecdotally from staff reports, they're thrilled, and that really drove putting in these UV systems. That I think we may have 1 or 2 more pools to put in UV systems, but at that point we were really sold, and so we've continued to do that just so that we can keep our trichloramine levels as low as we can in the pool environment for staff and obviously for our patrons as well, knowing in the background that pools are a leading cause potentially of childhood asthma, and as an organization, we take that very seriously as well. So moving along, maybe over time, and you guys want to run out of here, but once again, kind of UV, no UV, once again, not super strong statistics there, but so you can see that there's definitely a trend downward when we put in the UV systems in our pools. Pros and cons of UV. Basically, I'll flip to this. They're made of high-quality steel, but we seem to have corrosion problems, and that is a real challenge. This is expensive when you have to tear them apart and start again. So that has been a bit of a downside. And so this has been our sort of the pros and cons so far with our UV. Like I said, immediate subjective improvements. Everybody loves them. The installation is easy because you can't easily retrofit any pool with ozone. Ozone systems are very, very challenging, and there's still a lot more science, in our opinion anyway, is required before ozone really goes to the next level, and can be proven to be a leading way to minimize trichloramine levels in the pool environment. Relatively cheap. I mean, in the order of around $50,000 is the approximate cost of the installation. That's a challenge for a small organization. For a large organization, it's easier for us, obviously, being a large organization. Easy maintenance. Basically, you throw the light in there and you turn it on, and it stays on for 9 months, and then an alarm goes off and says that the intensity is starting to drop. You pull out the light bulb, you put in a new one, away you go. So the maintenance people love it. It's easy to maintain. They also have special wiper systems that constantly clean them too, so scum doesn't build up on the lights. And we've seen that there's no need to do superchlorinations, and just because you're zapping the water with so much UV, there's little chance of any organism ever surviving, be it Cryptosporidia, some of the ones that are Giardia, some of those that are really tough to get removed from water systems, is that a medium pressure light will really nail those ones. The cons, like I said, we've got our corrosion challenges. We learned the hard way, if you don't turn the lights off, because the pools will bounce back quite quickly with the chemical reaction. It's best to always keep the lights on. And one of the downsides, though, is we go through a lot more chemicals now, which is a bit of a challenge, is because that UV light, it's a very powerful energy source. It's good at breaking up mono and trichloramine. What I haven't plotted yet is the spectrum of how chlorine is broken down within the pool environment. And obviously our lamps are burning up the bleach as well. So we find we have slightly higher bleach usage. And as I showed you earlier, we're creating an acid, that hydrochloric acid, from the chemical reaction. So we have a few more challenges with balancing our pH. And so we're using more sodium bicarbonate to keep bringing the pool pH back to neutral. So that's been another, not a major con, but it's a trade-off of the technology. Sure.
I know that the sodium bicarbonate and that the acid, but is there no allowance for a lower chlorine in the pool because everything?
No, and that's a challenge. It's just the way the Health Act is written currently. And there's, oh, sorry. So Kay asked, can chlorine levels in the pool be dropped? Because I believe by law they can't drop low. The free chlorine level in pool water in the main swimming pool either can't go below 1 parts per million or 0.5 parts per million. But the trouble is that the controllers that monitor the free chlorine level in pools, they're not very accurate between 0.5 and 1. So if we could, we would love to run at around 0.2 to 0.5. That would be probably optimal in terms of a public health of having residual free chlorine in the pool and not burning up tons of chlorine at the same time. So in a perfect world, yes, maybe the Health Act could be changed, but that's not going to happen. And because UV, I mean, there's still a lot of science. Like there's a lot of questions out there too. But as we see it, that would be optimal if you could hover just below 0.5, and it would probably be very effective from a public health standpoint. I think in the essence of time, or how am I doing? Am I over time, or am I good?
You got 10 minutes.
Oh, okay, great. I still probably have a few too many slides, so I will make sure. Oh, so recently, some recent literature that I came across, because I gave this presentation a year ago, was that somewhere in the European Union, I can't quite remember, but looking at because as I said, statistically I can't show you anything, but other people have been able to show that they've seen chloramine reductions in water up to 80%. And for those of you who've maybe know a little bit about pool chemistry, is that they talk about free chlorine and combined chlorines, and so that's what that 0.2 milligrams per liter or 0.2 parts per million is relating to, the combined chlorines in pool water. So definitely if your combined chlorines, I believe, go over 1 part per million, that's when it's time to start throwing some more bleach in your pool. It's getting a little dirty and scummy. So so UV has been really good at maintaining that, really keeping the combined chlorines low. So other studies have been able to show that airborne trichloramine levels have been reduced by up to 30% in the pool environment. And also reduced water consumption in Europe, because in Europe they have slightly different health rules in pools around dilution, which we don't have here in BC. Around where in Europe they have these mandatory dilution. So every patron who comes in the door, they have to ensure that they dilute by so much, which, you know, in Europe with all those people and water issues, I guess from an environmental perspective, that's actually pretty tough what they're doing over there. But obviously they make do. And then disinfection products are generally all reduced, except, as I said, you know, every control sometimes is not perfect. One of those is chloroform is slightly increased, the production of chloroform. And chloroform is always produced whenever you're introducing chlorine into water, so it's in our potable water system, and there's lots of studies out there on that. And so I haven't shown you any data, but we did see a very small increase in chloroform levels, because we were collecting chloroform levels in the water throughout our study as well, and afterwards. And so the students doing the labs were also collecting water samples and having them analyzed. So as much as I trust the students, they were students, and so there was maybe some learning mishaps along the way, so we can't sort of assume that all of their data is perfect. But looking at it, you know, we did see a small trend up in chloroform levels, and others have seen that too, and there's studies on the potable water system that have also shown a linkage between UV and chloroform increasing. And chloroform, you know, has problems with, I believe, being a carcinogen, and also is puts women at risk of miscarriages if they're pregnant as well. So obviously, you know, some, you know, potential for concern there as well. And it's a topic within the public health literature. So just kind of going into a few other mitigation issues around, one could be You know, if you can't afford, so a UV system, you can add more air, more dilution, but once again, like I said, that's a very expensive way to do it. And once again, if your hot tub's belching out a lot of trichloramine and you don't have any sort of immediate way to capture that off-gassing, it's going to be a problem in your pool environment. And that was one of the problems with pool number 5, was that the exhaust intake used to be right next to the hot tub, so it never affected the whole environment. But when they put the hot tub on the other side of the facility, basically where the distribution was into the pool, everything was off-gassing out of the hot tub and then blowing all the way through the pool. And that's why we had so much trouble in pool number 5. Was just because the hot tub was taken away from the exhaust thing. So Ed, I knew you'd love that part. So, minimizing water features. You know, as a hygienist, I can stand up and say that, but in terms of if you're a facility operator, you're not so keen because it's all about the patron experience nowadays and all that capital expenditure on those pools. So, increasing dilution of hot tubs. I have recommended this to some municipalities as a quick interim measure to help them. And yeah, anyway, like I said, the city of Vancouver, we're very thrilled with the way UV systems operate, and we're, even though we have our challenges with them, we're not going to be turning the lights off anytime soon. And there is a surge tank. This is sort of unproven, but this could be another kind of economical method for organizations to try and force within a contained environment. So this whole tank setup would be underneath the pool, away from the patrons, where you can drive compressed air into a tank and then you vent the off-gassing out of the tank. You know, this is something that probably could be set up by the maintenance staff without too much trouble. And on the internet, there is kind of the instructions and measurements of how to do that. One of them being Michel Herré, who did all the initial studies around trichloramines in pools, and so he's been, you know, the kind of the grandfather of the whole trichloramine issue in pools. So. Any last questions? Like I said, we still have lots, but yeah, questions?